Sirio, es un honor para nosotros estar aquí para rendir homenaje a David Roth por su trabajo en Chalcatzingo. También queremos reconocer su trabajo excepcional y sus profundas percepciones en muchos aspectos sobre investigaciones del medio cognitivo. Estamos muy contentos de estar aquí entre ustedes, quienes han dado un gran conjunto de investigaciones en Chalcatzingo, y somos agradecidos de tener esta oportunidad de contribuir en este esfuerzo. También nos gustaría expresar nuestra gratitud a Mario Córdoba y Carolina Mesa para su apoyo y colaboración y su invitarnos a compartir nuestro trabajo con este grupo de estimados colegas. Y gracias a la gente que tiene disponibilidad para la presentación de conferencia. Yo creo mi insulto a sus lenguas es suficiente en este punto. Entonces, nuestra presentación va a continuar en inglés. For many years, researchers have made comparisons between similarities in Chalcatzingo and other Middle Formative Period sites. These observations are based on stone sculpture, architecture, and spatial relationships, ceramics and motifs, and greenstone assemblages. One of the first to recognize the possible inter-regional relationships is Miguel Covarrubias, who noted similarities in the style and iconography of carvings of Chalcatzingo and monuments at Tepoztlan. In 1953, Roman Vinachan discovered ceramics that he saw as comparable to those from the Valley of Mexico and concluded that a formative period settlement had been present at Chalcatzingo. In 1972, the Chalcatzingo Archaeological Project began to provide additional data that related the site to other settlements across Mesoamerica. An objective of our current work was to construct testable models for these interactions to allow us to assess degrees of similarity and contrast between components of the material culture and the observations of symbolic representations. One of the most recognizable mechanisms of this interaction was the carving of stone monuments. We will show you some of our work from other formative period sites as an example, and how we're using a number of methods and technologies to, one, address multiple research questions, two, to bring this information to the international community, and three, to assist in the management and preservation of monuments, architectural features, and landscapes. We'll also show you some results from our preliminary work here at Chalcatzingo.
So to start with, we'd like to just sort of overview why we think this is an important pan-Mesoamerican kind of project. Starting with why we're doing this, because these monuments are at such risk. We documented several of the pieces from Laguna in 2007. Right after we left the project, there was both flooding and vandalism. These things happen frequently. So does problems with air pollution, air quality. Once we bring things out of the ground, we are setting them up to deteriorate, essentially. So all of these sculptures are at risk. And even when we do documentation to the best of our available technologies, sometimes the records themselves are imperiled. So for example, here's a wonderful photograph of altar 4 from Laguna that's in archives at the Smithsonian. However, if you really look at this up close, the negatives themselves are being impacted by time. They're scratched, they have dirt on them, they're slides, and they're made into photographs later. So all of these records, even though we think we're doing the best that we possibly can, our records that we're doing today, eventually, are they going to stand the test of time? And so that's one of the things that we're trying to do, is make sure that we're creating an archive that is done in a stable way. And also, the way that these records are made can impact the way that we interpret things. So if we see things one way when we're in the field from one perspective, that can impact our interpretation later. For example, drawings. They're done usually from photographs. Sometimes a drawing is made from another drawing. So here we have drawings made of Monument 63 from La Venta. And let's just look at them in sequence and note the differences. And this is all the same monument. Does it matter? Maybe it impacts interpretation. Maybe this is a lasting record. This might be all we ever have of this monument. Maybe the monument gets vandalized or looted, and all we have are photographs or drawings. And so if we don't do it in the best possible way, we can impact our interpretations later. Note that the one on the end is done directly from laser scan data, and we'll be showing you some more of that later. This is just to say that, again, we should use more than just one technology, perhaps. So here we're using a multiple range of different types of technologies when we're documenting pieces, not just photography, not just laser scanning, not just documenting terrain, but in total, all of these things. One instrumentation, one way of looking at it, we have found we're trying to do it from multiple ways. And
this is just a matter of scale, depending on the type of applications that you're going to have. This is all from the same monument, steel 5 the Tepoztlan. This type of documentation gives you simply the morphology of the piece. These are all laser scans, and then a different scanner for a little bit more detail, and then a close-range scanner brings out the greatest amount of detail.
So it's just basically to say one size, one instrument doesn't fit every application. So what we often do on a project is we have to integrate multiple types of instrumentation. So on a project, we will oftentimes have 3 or 4 different types of scanners that we're actually documenting different ways. So we thought we would just show some results from a few projects that we're doing in Mesoamerica. This one was concluded in Guatemala at the site of Chalcatzingo. And we feel this is a good sort of showcase example for the work that we will have coming up with Chalcatzingo, because it shows all of these multiple ways of getting to know the site and sharing the data.
Just to give you an idea, this site is about 6.5 square miles, so it's a pretty good sized piece of property.
So this is just a little visualization of sort of an overview of the project. All of our projects, we're really trying to also include training and technology transfer as part of it, because when we leave, we want to make sure that we can continue the project. So just to sort of take you into the site. And again, like Travis was saying, this is a really large site, and we set up control, and we actually mapped and utilized maps that were made in the 1970s by University of California, Berkeley. Multiple different scales had to be considered over wide spaces. So we use multiple laser scanners, we use aerial and remote sensing, special imaging kinds of techniques. And again, just little variations, remapping, verifying positions of structures. A lot of times you'll see things brought out about alignments and other different types of relationships within a site. And so it's good to have best available technologies to actually know where you're at spatially. You're looking at laser scan data done from a much wider scale. This is to capture a feature within a structure. These are all, they look like photographs. Essentially, this is a cloud of points, X, Y, and Z, that are accurate to about 2 millimeters. And then what we do is begin modeling the features, and then rendering CAD drawings and understandings of the site based on these best available data. This was a water feature that we were very interested in elevation of the terrains and how water might have moved across this feature. So it's the same kind of technology, just done at a different scale. This is, again, a different type of scanner that was utilized to capture all of the structures within the site so that we can then structure and model and understand the relationship of the larger terrain down to the smaller area, down to the monument. Monument documentation we're doing with multiple types of scanners as well, depending on the detail and depending on the environmental conditions. Some scanners work very well in daylight hours, others work very well during nighttime hours. And so we mix this up and also combine traditional and different types of imaging techniques as well. This is a really good example of what is happening to monuments through time, I think. If you look at the same monument, the historic image from 1972 when it just came out of the ground, and this same monument as it's seen in 2010 now. So again, why it's so important to document these pieces before that texture just erodes. Part of the problem has been the contact that we make as archaeologists, that we're doing the rubbings, and actually, right before we did this project, they had done fiberglass molds of a lot of pieces. And it actually breaks that surface patina so that then it exposes the pieces to the elements, and we're seeing actually an orange mold and a lichen growth all over these pieces that have been documented this way. So we're just trying to use best available technologies to capture these in all three dimensions, which many of these pieces are carved in the round as well. Common Overview is another project site that we did in Guatemala, where we are doing some advanced computer techniques, where we're actually utilizing computer modeling to do edge detection and to extract data directly from the monuments so that we know what's actually carved, rather than just relying on what we might see. And I believe this is an example of a total modeling that was done of altar floor from Laventa. And again, important to understand the sculpture in 3 dimensions, the way that it was intended to be seen actually by the people that carved it. This was scanned in we acquired the data in about 1.5 hours, and then it takes us about a week of lab time to process this. So it's fairly rapid. We can cover a whole site, and we can cover multiple sculptures very cost-effectively and efficiently. And why it's important to consider things even from areas that aren't carved, or that we don't perceive as containing valuable information, with all the mutilation, the recycling, reuse of this piece. Another piece, again, this piece is pretty well preserved. It's in a museum. It's in, this piece is Monument 44 from Laventa. And it's actually, though, if you visit the SECOM Museum in Villahermosa, this piece is up against the wall. And so you don't really appreciate the full 3D aspect of the carving of this piece, as well as the forensic detail of all the intentional breaks. And the other thing that we would like to express is that these data have multiple purposes. So they're great for both analysis and research, but also for the public engagement, to include and utilize for museum development and interpretive aspects.
This is a monument, San Lorenzo had one when it was found in the 40s. You can see that it's just coming out of the ground. There was a mold made of it, and it now resides, the mold now resides, the casting, I should say, in the Smithsonian The whole head isn't there because only part of it was exposed, and the whole back of the head is now plywood with the frame. But we did scan this in hopes that one day we'll get to be able to document the original and be able to compare the two and see what changes occurred over time.
These are some of the resulting models. This is raw data sort of initially processed. And again, we can capture this data. That this project was, again, about a 2-hour project to collect the data, and then you know, about a half a day to process it, and then maybe a week to model it fully. So now all of these can be shared online, and that's our intent with all of these sites and all of these data, is to completely open this and share it with both other researchers, with the general public. We want it to be in full 3D and contain all of the context information and details. And we also are including in our database a way that people can upload or participate with the site. So if they have information or old photos, historic photos are sometimes the best record that we have of pieces because they have deteriorated through time. So we're hoping to encourage these kinds of things as part of our database project. So this kind of brings us up to what we're doing now and why we want to document Chalcatzingo. So this is very preliminary. We've done 2 short field projects at Chalcatzingo to test some new instrumentation and to begin collaboration and work. We came and met Mario and Carolina a couple of years ago, and they graciously sort of wrote us into a lot of the project that they were doing at the time, which was taking care of and trying to protect some of these monuments and restore some of the site. And so we felt Chalcatzingo, for a number of reasons, was a very important addition to the 3D mesodatabase.
So we work here in southern Guatemala. We worked up in the area of La Venta and now Chalcatzingo, and our objective is to try to capture as much formative period material as we can. But Chalcatzingo, we feel, is a very, very important part of the overall process of interregional interaction.
So this is just Chalcatzingo today, a little bit. I did this at the hotel, so. This is just to show you that the land use has probably changed since many of you have seen the site. There's quite a bit of agricultural activity and a lot of development now that is all around the site. The red dots you see, by the way, are preliminary GPS work that we've done to document locations of all of the monuments within the site. And we did a site sort of walkthrough and mapped in all of the features as well. And now we have photo tagged all of these, and we're going to make this available on Google Earth. Why? Because that's how a lot of people get their information and want to see things and visualize things. And this can help in understanding the landscape from a much broader perspective. So again, we just want to really say thank you not only for all of the work that has been done, that is the foundation for what we do going forward, but also how honored we are to be participating with our partners in Mexico on this project as well. We have worked with them intimately to sort of, they show us what they feel are imperiled at the site, what they think is important to document from a management perspective, from a conservation perspective, and from an interpretation perspective. So all of these things are playing together with our own research interests as well. Many of these pieces are very imperiled. They've been restored through time, but there's still concerns over their long-term longevity at the site. Here you see spalling and cracking, which has been there. But if we were to lose or that piece of El Rey to shear off, what way would we have to restore it or to know what was there? They've been doing a lot of work at the site already with protecting monuments and documenting monuments. There's been much work that's already been done, and we definitely want to take advantage of all of that foundational work that's been done. And we want to pull all this data together into the database. So here we're taking, they've already done a wonderful survey, and there's been mapping surveys through the year. Ken Hurt's not here, but there's been multiple maps that have been made through time. And we are incorporating those maps into the modern day landscape, referencing them to the land today, and also including new information that we're collecting, which here you see the photo points and the photo logs that we've made. Same here. And we're doing landscapes and terrain documentation. This is the pyramid today. This is a point cloud taken from terrestrial LiDAR. It's essentially a laser scanner on a tripod that covers 120 meters out. And just to kind of give you an example of what it's collecting, so these are all X, Y, and Z coordinates that you're seeing. So this is like a topo map, just really, really dense, so that it looks like a photograph. So we did this over just a small area. This was about 30 minutes, 40 minutes of collection time that we did Sunday, this week. So this is just to show you how rapid it is, okay? So we can cover large areas. Out to, some instruments are going out to 1 kilometer. And we can take measurements on all of this. You see, this is totally to 2 millimeters accurate. So we can do volumetrics, we can do distances, we can look at relationships between structures and monuments. And then we can come back and model features as well. So here's the altar we've been seeing on conference, right? And when you see it today, and it's sort of under the Palapa hut roof here, it's sometimes hard to interpret if you don't know much about the site. You're just visiting. You're not sure kind of what it is. There's a sign there. So one of the things we're looking to do with this is to have another usage for our data, which is maybe increasing interpretation and public understanding, as well as our own preservation conservation. So here we just see some preliminary models. And again, this was done with data that we literally just collected. So again, it's a different type of instrument. This is collecting a wider area, and then we're able to utilize that data for multiple purposes here to create visualization. And then we're also doing the same thing with maybe different grades of instruments to get closer range data. In this case, we're looking at sculpture. So this is one of the feline monuments that we've seen, Monument 31. So here's some of the details that we've extracted from Monument 31. And the other thing that we can do with this data as well is consider it in relation to two-dimensional data that's already been done. So we have CAD drawings, we have previous drawings and rubbings that have been made, and we can consider them in relationship. We can look at what's happening to the monument through time. There's multiple things that we can do with this type of data, including visualizations for the public and to show the object in 3D. And we can even create rubbings without rubbing it. So we can make it look that way too. We can do digital line extraction, consider symbols in isolation. And again, so this piece was done on Saturday. So this is the Volador, Monument 12. And this is very preliminary, you're seeing it raw, but this is El Rey. So we're missing a piece here because there's a stone in the way now. And so when we come back to do the bigger project, we'll be gathering that data. This is the new feline, you saw it in Fash's, it's Monument 41. You saw it earlier in Fash's presentation. Again, just showing line extraction. This is all done from the digital scan data. And then this is a piece that hopefully, if you visit the site on tomorrow, you're going to see this is the new altar. We scanned this the last day of the field. Oh, no, we scanned this Monday. Yeah. So this is the new altar. 44. So here just showing the changing of the light to be able to extract some of the detail. And this is not the final model, but this is just to show you how rapid we can do this and share it. Complete measurement, we can look at all the reuse and recycling on the piece. We can compare this piece now to other pieces. This is the one right under we did last night. So we did this before dinner last night. And then after dinner, we modeled it. And again, very preliminary, it's not our final model, but we can share it. We can create everything we do, by the way. We are working with our counterparts. They don't have to have any special software. We're working in ways where they have free software, okay? Totally free viewers. PDF, Adobe PDFs. We make them in 3D. We can share these, you can measure, you can do all kinds of things, change the light. So there's no special software required. And so that makes it very easy to work together. Omar, we've been tweeting and sending each other images and three-dimensional models, and it's worked out really well. So this is just to show you the database itself as we move forward, as we go to the larger Chalcatzingo project. Some of the things that we're going to want to do with the data that we're collecting. Again, this is a piece very crudely modeled. We just collected this data on Sunday. This is Monument 21. Right? And so some of the things that we're working on is computer vision techniques to be able to extract details automatically, to be able to take those details. We're calling it semi-automatic archaeological research engine, big acronym. What it is it's going to be an algorithm within our database where all of the pieces that we scan or have two-dimensional accurate details for, we can compare symbols. So if you go on Google and you search for images and all of a sudden Google finds all those images, we're going to be able to do that with symbols. So all the icons, we are creating a dictionary and we'll be able to compare sites and contrast those symbols. So how similar are sites to one another? We can begin to quantify that. How similar are pieces to one another? We can quantify that. So that we hope to actually embed within as a function within our database. And then also using shape-based analysis, all kinds of three-dimensional analysis to be able to look for similarities and patterns. You can't see this very well, but we can take a piece that's almost completely abraded or washed out, and we can extract detail from it so that we can verify what is actually carved on the surface. So the big thing is to be able to compare, contrast, and to consider data without the subjectivity that's inherent to drawings. Even photographs, you take them from a perspective. You know, you're choosing where to take a photo from. The scan data is not, it's objective. It's collecting all of the information. And so that's what we're hoping to move forward with. This is just to give you an example of our symbols, how we're using computer intelligence to be able to do this very rapidly. This is another interesting function. If we scan things today, and we scan things 5 years from now, which we've now done it actually at Tepoztlan, we can compare those scans and see what's happening to the piece through time. So from monitoring, this is actually just comparing 2 different scans, just to show you the color differences. The reds are where there's differences occurring in the scans here. So we can look for inherent differences in 3D data. And then finally, we just want to say that one of the ultimate goals of this project is to also share. And so one of the things that we're trying to do is teach in new ways. And so at our university, we now have a 3-dimensional visualization center, brand new. So this fall, we will begin teaching classes in it. We're teaching a museum class, and we're also teaching a technology for heritage preservation class. We have rapid prototyping. We're actually printing things in 3 dimensions. We're looking at data in different ways. We want to be able to essentially work with other universities and host classes together. So universities here, universities in the United States working together in real time is a real possibility. study, right? But we can share information and we can learn in different ways and more, it's going to be better learning together. This is just to show you just a quick example of actually using some of this data in the classroom. This is a full wall that people can actually see in 3 dimensions. So students taking this class will actually be able to study iconography in 3 dimensions and see it on a full wall. We can extract details. Here we're doing digital drawings. So it's a different way of learning. It's a different way of presenting and maybe discovering. Because archaeology in the future might be different. So that's where we're headed, and that's where we're trying to be with Chalcatzingo as the prime example. So in conclusion, we're just, we have a lot of goals moving forward, and we're trying to connect all these databases and make them very open to the public and in a very sharing, collaborative kind of atmosphere. And we're hoping that as an end result of all of this, that heritage management and education can improve and benefit from all of this.